Hey guys, it is Campbell here. Today we're going to be going over the 2024 AP Calculus BC FRQ number 4. So this question reads, the graph of the differentiable function f shown for -6 to 7 has a horizontal tangent at x equals -2 and is linear for 0 to 7 inclusive. Let R be the region in the second quadrant bounded by the graph of f, the vertical line x equals -6, and the x and y axes. Region R has an area 12. Let's go ahead and underline the information that we think is probably going to be important for this question. So it tells us region R has an area of 12. It tells us that there is a horizontal tangent at x equals -2. And it tells us that the graph is linear for 0 to 7 inclusive. Now let's go ahead and do part A. Part A says the function g is defined by g of x equals the integral from 0 to x f of t dt. Find the values of g of -6, g of 4, and g of 6. So let's just go ahead and write down that g of x equals the integral from 0 to x of f of t. And now let's go ahead and start. G of -6 is going to be equal to the integral from 0 to -6 of f of t. Now, it tells us the information that the region R, which is from -6 to 0, has an area of 12. Remember that when we do an integral backwards, when we go from 0 to -6, it is going to be this area negative. So we know that this is just going to be -12. Next up we have g of 4. That is going to be the integral from 0 to 4 of f of t. To make sure that's a 0. So it does tell us that it is linear for 0 to 7, which means from 0 to 4, this is going to be linear, which means we just have a triangle here. So we know the area is going to be 1/2 times the base, which is 4, times the height, which is 2, which is just going to give us an area of 4 for g of 4. And finally, we've got g of 6, which is the integral from 0 to 6 of f of t. And since we know that this line is, or that this function is linear from 0 to 7, we know that this is also going to be a triangle. So from 0 to 6, we just have another one right here, which means it's going to be equal to our area from 0 to 4 plus our area from 4 to 6. So we know that this is just going to be 4, and this is going to be 1/2 times the base, which is 2, times the height, which is -1, leaving us with -1, which is going to be 3 for g of 6. And that's going to be our final answer for part A. Alright, let's go ahead and move on to part B. Part B says for the function g defined in part A, find all values of x in the interval 0 to 6 inclusive, at which the graph of g has a critical point. So, once again, recall that g of x is equal to the integral from 0 to x of f of t. It says find all values of x in the interval 0 to 6 at which the graph of g has a critical point. So remember a critical point where the derivative is equal to 0, so we need to find where g prime of x equals 0. We know that g prime of x is going to be equal to f of x. Because remember, when we derive something like this, we're going to take the derivative outside of the integral sign, and we're going to plug in our limit, and then we're going to multiply by the derivative of that, and then add our other limit and multiply by the derivative of that, which, of course, for the bottom limit is just going to be 0. So we know that g prime of x equals f of x. So we need to find where f of x is equal to 0. Let's go ahead and scroll back up to our graph here. We know that f of x is equal to 0, and it asks us from 0 to 6. Well, the only place where f of x equals 0 is at x equals 4. So f of 4 equals g prime of 4, which equals 0. So g has a critical point at x equals 4, since g prime of 4, which equals f of 4, equals 0. And that's all the justification we need for part B. And finally, we're going to move on to part C here. The function h is defined by h of x equals the integral from -6 to x of f prime of t dt. Find the values of h of 6, h prime of 6, and h double prime of 6. Show the work that leads to your answers. So we're going to go ahead and write that down. H of x equals the integral from -6 to x of f prime of t dt. It wants us to find h of 6, and that is going to be equal to the integral from -6 to 6 of f prime of t dt. Now remember, we're just going to take the antiderivative of this, which is just going to be f, and we're going to plug in the upper limit minus the lower limit. Let's go ahead and scroll back up to look at our graph. F of 6 is going to be -1, and f of -6 is going to be just 0.5. So we've got -1 minus 0.5, which is going to be -1.5. And there is our first answer. Next up, it wants us to find h prime of 6. So h prime of x is just going to be equal to f prime of x. So h prime of 6 is going to be equal to f prime of 6. So once again, let's go ahead and scroll back up. We know that at x equals 6, and actually from 0 to 7, that this is linear. So all we need to do is just figure out the slope. It should be pretty easy. You can figure it out from this section alone. Slope is going to be -1/2. As you can see, we go down and go over 2. So f of -6 is going to be -1/2. And finally, it asks us for h double prime of 6. So h double prime of x is, of course, since h prime is equal to f prime, h double prime is going to be equal to f double prime of x. And since f double prime is just the derivative of this, it is going to be 0, because the derivative of a constant is always 0. And that was it for question 4. I mean, that was a pretty simple question. All just math and kind of intuitively knowing if you're given an integral function, knowing that the derivative is just the function with the limits plugged in. We didn't even get really a difficult, fundamental theorem question where it asks us, plug in the limits and then take the derivative, and a pretty simple question. So I'm going to be going over, once again, I'll be doing all of the questions in the BC FRQ, and I'll be doing all of the AB FRQ questions. If there's anything that you guys want me to cover, please leave a comment and let me know. If you found this enjoyable, if you learned something, if you found this helpful, please consider leaving a like and subscribing, and I will see you guys next time. Bye.